Hello and welcome to a recipe for a good oat crop, a presentation on the response of milling oats to changes in nitrogen rate, nitrogen placement, and phosphorus placement. This presentation will highlight the results of demonstration projects in 2022 that were conducted at the Northeast Agriculture Research Foundation in Melfort, Saskatchewan, and the Western Applied Research Corporation in Scott, Saskatchewan. My name is David McTaggart, and I work for NARF at the Melfort Research Farm in the heart of the Carrot River Valley in northeastern Saskatchewan. Before I begin, I would like to thank our major funders for this research project that include the Saskatchewan Ministry of Agriculture through their ADOPT program and the Saskatchewan Oats Development Commission for administering this project. Thank you very much for your support. The key question that guides this project is, for milling oat performance, what is that impact of these three factors of nitrogen rate, nitrogen placement, and phosphorus placement? What I'm going to do is give you the answers of what we found first, and then I'll prove it to you, hopefully, as we go through the presentation. And so this, once again, was based on work that was conducted at NARF in 2022 in the northeast part of the province, and in that same year at Wark in the west central part of the province. So what did we find? Well, the biggest part of this is that location matters when it comes to the response of your oat crop to fertility. In Melfort, we saw more of a yield response to added nitrogen and improvements in yield when phosphorus was placed in the seed row versus in the sideband. Now, when you compare that to Scott, there was minimal yield response there. And also we saw decreasing test weights as nitrogen rates increased. Now at both sites, we did see lower yield as nitrogen was placed further away from that seed row in the mid row versus in the sideband at low nitrogen rates. And lastly, just overall in 2022, there was quite a low yield response to increasing nitrogen rate. Now, I think it's always important for us in research to be able to explain why our work is worthwhile, why you should spend your time to go over what we found, and hopefully I'm able to provide some of that in the next few minutes. So, as farmers and agronomists, these might be just some of the many ways of why fertilizer management, as far as rates and placements, is important to your operation. In the last couple of years, we've seen fertilizer prices increase dramatically. And so if we can fine-tune our management of this, it has a key role to play in the profitability of our farming operations. And not only is proper fertilizer management important to be profitable, but it's also important in the conversation that's been a hot button issue lately surrounding fertilizer management and its environmental impact. Also, time management at seeding. Can we manage our amount of time that we spend filling up based on how much fertilizer we're using? And also some various other factors that I mentioned here on the slides. So hopefully some of these connect to you. So now let's hop into the design of our demonstration. As was mentioned before, there were two sites in this experiment. Melfort was in the black soil zone of northeastern Saskatchewan, marked by one of our red stars there, on silty clay soil, with about a 9% soil organic matter and a pH of 5.8 in the top 6 inches. Scott, on the other hand, was in the dark brown soil zone, what you'd see that red star on the left of the map there, on silty loam soil with 4.4% soil organic matter and a pH of 5.4 in that top 6 inches. Now both sites were seeded with a Fabro plot seeder with knife type openers. However, they varied in seeding row spacing, with Melfort on 12-inch rows and Scott on 10-inch rows. Now, CDC Arborg was the variety that was used for this experiment, and it was planted to hit a target density of 350 plants per meter squared. However, after I looked at the results, on average, it was closer to about 250. Our nitrogen source was granular urea, 4600, and for phosphorus we used monoammonium phosphate of 11520. Now phosphorus was put down at 36 pounds of P2O5 per acre, and you'll see the nitrogen rates here in just about in a second. Now for our experimental design here, we had, again, you see those three factors. We have nitrogen placement, nitrogen rate, and phosphorus placement. And this experiment was a little bit different in its design. To be able to get the specific influence of each of the three factors, we had to analyze them in treatment groups. I'll just briefly mention that in the results that come along here in a little bit. But you can see that our nitrogen rates were 0, 67, 89, and 112 pounds per acre. So now let's move sections and look at what were the key results of our demonstration. And the first set of results we're going to be looking at is what was the impact of nitrogen rate on grain yield based on the research location. And like I mentioned in the previous slide, to tease out the effects of nitrogen rate, we're going to be using the treatment group that includes treatments 2 and 4 through 9. So what can we walk away with from this slide? So one thing I want you to notice, or that you might be wondering, is what are those letters on top of the bars in our graph here? And so these are used to show which treatments were significantly different from each other. So if bars share a common letter, they are similar to each other. But if they don't have common letters, they are significantly different from each other. So the key result that we can walk away with from this slide is that, pretty plain and simple, there wasn't a big nitrogen response at either of our sites in 2022. Now in Melfort, we did see a significant increase in yield with that first addition of nitrogen from 0 to 67 pounds per acre. But after that, there was no significant increase in yield. Then at Scott, all of those four nitrogen rates were statistically similar when it came to their grain yield. Now I did a rough economic analysis using the Saskatchewan Crop Production Guide and a urea price of $1,120 per metric ton, and that was from May of 2020 in and around the Melfort area. And then I used a full cash bids price that was on the Saskatchewan Ministry of Agriculture website, selling oats at $3.66 per bushel, and that might be a little bit lower than what you sold your oats for or forward contracted your oats for. So just bear that in mind when I'm talking about these numbers here. But what I saw out of my rough economics was that while maybe there wasn't significant improvements in yield at Melfort by increasing that nitrogen rate beyond 67 pounds per acre, we did see that at the 89 pounds of nitrogen per acre, there was still a positive return on investment by adding that amount of nitrogen there. So just something to keep in mind. But at Scott, there was a negative return on investment for each addition of nitrogen beyond that check. So something to be mindful of. Now, other results that we're not seeing on this slide are that higher nitrogen rates did reduce our stand density at both sides, so thinned out our stand, but this did not have a negative impact on yield. And at Scott, we saw that increasing nitrogen rates significantly delayed maturity. However, this was not the case at Melfort. And for Scott, that significant delay in maturity was probably around 2, maybe 3 days. So the next topic we're going to cover is what is the impact of nitrogen rate on our oat test weight depending on our research location. So it's been fairly well documented that increasing nitrogen rates can decrease the test weight of your milling oats, which leads to grading penalties at the elevator. So we can walk away from this slide with two major take-homes. First off is that Scott had much lower test weights than at Melfort, and that's similar to what we saw with yield. And when we look at Scott specifically, most of the oats receiving any added nitrogen were below the 230 grams per half liter that could lead to them being rejected for milling purposes. And then when we look at Melfort, we saw that there was no negative impact of increasing nitrogen rates on test weights. So now we're going to shift gears a little bit, moving away from that interaction between nitrogen rate and research location, and now looking at the interaction between nitrogen rate and nitrogen placement. So what can we draw from this slide? First off, this reinforces what we saw previously, that there's that significant yield benefit by adding that first 67 pounds of nitrogen, but afterwards, as you increase that rate, there was no significant yield difference. And another thing that we can see is in comparing 67 pounds of nitrogen in the mid-row to 89 pounds of nitrogen in the sideband, and we do see that those are significantly different from each other. And by looking at these trends, we can see that there was a difference, even if it wasn't significantly different, between 67 pounds of nitrogen in the mid-row and 67 pounds of nitrogen in the sideband, even if that wasn't statistically different. And so what that might be telling us is that if we are putting on that lower rate of nitrogen on our oats, it might be beneficial to place that a little bit closer to the seedling in that sideband. But we don't have, again, those significant differences to say that for sure. All right, now we are on to our final pane of results here, where we're looking at what was the impact of the interaction between phosphorus placement and our research location on our oat yield. And what our main take home from this slide can be is that the results depended on which location you were at. So overall, even though it's not shown on this slide, we did see a significant benefit in increasing yield by adding that 36 pounds of P2O5 per acre in the form of monoammonium phosphate. And as far as placement goes, there were only significant differences in yield based on phosphorus placement at Melfort, where seed row phosphate out-yielded side-banded phosphorus. And just something to keep in mind is that we did keep our rates of phosphorus at less than the current seed-safe rate of 50 pounds of P2O5 per acre for cereal crops. So with these one-year demonstrations, I think it's always important to look at these results with a bit of a grain of salt. And that's just because that they looked at a relatively narrow range of environmental conditions. So let's just keep this in mind, and what we can do to help us is to look at previous demos on a similar topic. And so for this, I'll be using for comparison a 2019 demonstration that was conducted at Yorkton, Indian Head, and Melfort, and then also a demonstration at Yorkton in 2020. So in our demo in 2022, we saw that there was a relatively low yield response to added nitrogen. And why might this have been? So first off is potentially the higher than normal residual soil nitrogen that we had. And a main influence on this was the 2021 drought. So for example, in Melfort in the spring of 2022, our residual soil nitrogen levels were around 71 pounds of nitrogen per acre in the top 12 inches of the soil, while at Scott, the residual soil nitrogen was 24 pounds per acre in the top 12 inches of the soil. Now, in comparison to that 2019 study of oat responses to nitrogen rates in Melfort, there was at this time 30 pounds of nitrogen per acre in the top 12 inches of soil. And in that demo in 2019, there was a much higher response to added nitrogen, where there was significant yield increases, even all the way up to 170 pounds of added nitrogen per acre. Another factor that might have influenced the low end response in 2022, that end response to yield, could have been the weather. So for example, Melfort was drier and warmer than normal than in those conditions of from July onward in the growing season. And Scott was drier than average throughout the growing season except for in July, and from June through August was warmer than normal. And we see that in the drier conditions like Indian Head in 2019 and Yorkton in 2020, various oat varieties have shown to be unresponsive to the highest nitrogen rates. But when we look at Yorkton and Melfort in 2019, there were those significant yield increases up to 170 pounds of nitrogen per acre. And in those years at those two sites, we saw that July and August was cooler than normal. And another thing that we saw, particularly at Scott, was that increasing our nitrogen rates decreased our test weights. Now, the stability of test weights under increasing nitrogen has been documented before at Melfort in 2019. However, that's not to say anywhere in the black soil zone you can increase your nitrogen rates through the roof and your test weights won't change. We have seen that same increasing nitrogen rates, decreasing test weights documented before at sites like Yorkton and Indian Head. So in those conditions, farmers, they will never be able to completely eliminate the risk of low test weights. However, by managing nitrogen appropriately and not applying too much, and choosing a variety with a high test weight, farmers can mitigate the risk of having low test weights when they take their oats to the elevator. And lastly, just something to always keep in mind with your crop's response to phosphorus is your soil pH. As we dip below a pH of 6, the availability of phosphorus in the soil is significantly reduced. So we should always keep this in mind when we are looking at managing our fields, and something for us to put into our crop management plans going into the future. So now that we've made it to the end of the presentation, what can we walk away with? So first, in regards to nitrogen rates, we saw that there was no significant yield benefit in Melfort to add nitrogen beyond 67 pounds per acre in 2022. However, when we looked at the economics of it, comparing the cost of nitrogen to the price we'd sell our oats at, there was a positive return on investment up to 89 pounds of nitrogen per acre. Now at Scott, we did not see any significant yield benefit, or also when it came to the economics of adding additional nitrogen in 2022. And then also we saw that the more prominent negative effect of increasing nitrogen rates that would then decrease your test weights. And just always keep in mind how the environment of your year will affect response to nitrogen as well. Now when it comes to nitrogen placement, we saw that there was a trend to show that at low rates of nitrogen, like that 67 pounds of N per acre, it's beneficial to get that nitrogen closer to that oat seedling. And then finally, when it comes to phosphorus placement, at Melfort only, we saw a benefit to placing that phosphorus in the seed row versus in the sideband. Thank you very much for tuning into this presentation. And for more information on research and demonstration projects completed by the Northeast Ag Research Foundation, please feel free to find us on our website or on Twitter. Thanks and have a great day.